Alrighty, hey gang. Well, welcome back. So today we're going to look at the tiny masonry cook stove, and we are going to talk about how to use it, how it runs, what your options are for layout, things like that, air settings, some of the questions you guys have been asking I'll try and cover, and stuff like that. So here we go. So I'm not going to start it. It's been burning. It's what time now? It's 9 o'clock in the morning. And it's been burning. I actually got up at about 3 in the morning and lit it. And then I put another load in at about 5:30 probably. Yeah, and then I think I had one more load in there. Oh, probably at 8 or so. No, 7. Now it's 9. Yeah, so it's just about out. There's just coals in there. And so my point is that the chimney's warm, the whole thing is kind of warm, so it's not going to be at its most efficient. But what I mostly wanted to show you was how to load on top of your old load and what you should expect and how to run the air settings and things like that. So let's get started. So you're hearing some buzzing behind me, and that is the Testo, and she's running right now, and we'll just spin around real quick and take a look at what it's telling us there. And so it's just coals, 20% oxygen, you know, that means it's pretty much almost full room air, and 1200 parts per million carbon monoxide, undiluted. So it's just kind of cruising on some coals, and as they do in the coaling stage, and it's just about out. So what you want to do when you load into the hot box is you want to try and let those coals burn all the way down, and not all the way down, but you want them to at least be focused up there in the front. Here's another little tip for you guys. This is a really long stainless. This is a really long stainless tablespoon, and if you get yourself a long metal poker like this, you can actually use this through the primary air hole to use it as a fire poker, and you can adjust your wood and stuff like that in there. So sometimes what I'll do is I'll just adjust those coals so that they're all up there by the secondary air tube, so that when you put your new wood in, it burns from the back relative to us, so it starts the burn closest to the air tube, which is exactly what we want. And that's how you want to start your fires as well. Now, if you aren't familiar with starting a batch box, I've got a video where I light the aluminum series version of this stove. It's using ceramic fiber, built using ceramic fiber like this. It's very similar, and you can see my lighting technique there. Another great thing to talk about while we're here is the insulated firebox versus the high mass firebox. One of the beauties of the insulated firebox is that there's no heat contained within those walls. There's a little bit, but not much. What that means for your burn is that you aren't going to initiate combustion out here in the front of the firebox from the hot mass radiating onto the wood, which means that you aren't going to be off-gassing a bunch of gas right from the start before the thing's hot. And that's one of the main reasons why high-mass fireboxes and batch box can be dirty on the second and third loads. By the time you get that firebox all heated up, it just becomes, you know, it just off-gasses the wood instantly, basically, so it's very hard to get a controlled burn. So that's from a performance standpoint. From a loading and everything else standpoint, now everyone loves to talk about how awful it's going to be to have just soft ceramic fiberboard or insulated bricks in a firebox, but everyone is speculating, in my opinion. You know, we all think we know how it's going to go, but until you do it, you really don't. Now, one of the reasons the speculating leads to thinking that this is all going to just wear right away instantly is because in a high mass firebox with fire brick or something in there, you can't get anywhere near the thing to load it. It's too hot. It will burn your hand. Your face right here, my camera would be melting right now. And because of that, you tend to sort of cower down out of the way, and you jam wood in there, and you don't pay attention to what you're doing. With an insulated firebox, even when things are have been super hot and the stove's been burning for a long time, you can stick your hand in there. I mean, we couldn't keep it there for a long time, but I'm not singeing the hair off my hand. So that's one of the biggest advantages, one of the reasons why an insulated firebox does work really quite well in practice, is that in practice you just aren't stuffing another piece of wood on top of a giant coal bed and trying to keep everything out of there and wearing mitts and welding gloves or whatever you're doing. You don't need to do that if you have a firebox like this. So you also don't get a big coal bed because the bottom is insulated. It feeds that heat back into the coals. That's one of the things about, we were talking recently about some cooling designs on Donkey's board, and one caution there: you do want insulation underneath the coals. You want to feed that heat back into the coals. High mass is just as bad. Fire brick sucks it right out of there, and that's why you get coals. With this, you really have almost no coals left. So enough jabbering. Let's go ahead and load this. So when you load it, you know, you can stick your hand in there and load it carefully, and you just want to try and get it as close to the front. Dig for some wood here, as close to the front of the firebox as you can. So, and this is a pretty big piece, but I think it'll go, or the back of the firebox, excuse me. So that's looking pretty good. I'm going to see if I can find one more little piece of fur in here. And I don't think I'm going to, so we'll just run with 2, and that's okay. So I don't know if we got flame, and I'm going to help it get flame. And I wouldn't always do this, but since we have the testo going and since it's on film, if I wait for it to fire off, it'll just be blowing carbon monoxide until we get actual flame. So I'm just going to stick a match in the back end there, and since everything's hot, it should just take right off. There it goes. Alright, so now, just for fun, we can turn around and watch the CO, and it's probably going to go up, and it's probably going to go up for a little while, but it might not. The stove's pretty warm. You can see the stack temp over there is 199, 200, so our efficiency isn't going to be great because of that. Normally, like I said, I wouldn't be burning again. This has been burning for more than enough time. It's really warm in here, and it's warm outside. So this isn't going to be the most efficient run, but we're going to talk about how to run it and what to do. So actually, it's not really spiking too bad. It's taken off slow. It's probably still going to rise, but we won't stand here and look at it. We'll talk about some other things and get back to that in a minute. Okay, so back to the stove. Alrighty, so that's how you load her. That's the firebox discussion. I'm going through my notes here. So let's talk about air. So right now, it's a hot stove. That means it's going to pull pretty hard. And normally what I would do is just leave things wide open. Now, I should have done this before. I've got a little something in there, a little ceramic fiberboard in there, closing off the secondary air a little bit as I've been playing with things. That's thanks to Kieran's questioning, asking me if that was a good idea. And Kieran, yes, there are some advantages to closing off secondary air, but we'll get to that in just a minute. So let's talk about air settings. So here we go. We just kind of lit off. It's mostly burning there in the back of the stove like we want it to. We've got a little bit of fire here up front, which isn't great, but that's okay. Our testo says that, yeah, we spiked up there to over 1,000 parts per million, and now we're going to come back down. It's dropping pretty quickly here as is the air, so we'll start to get our real efficiencies and things here in another few minutes. So I'm going to mess with it, so we're not going to get to see all that, but at any rate, we might get to see some of it. Running it wide open is how you would normally start from scratch, and if you want maximum heat out of the stove, of course, that's how you're going to run it. When cooking on top, that's going to give you your hottest temperatures, although that's by no means required to even boil water. This thing cooks really hot. If you cook with it wide open like this, and you cook right over the riser in a cast iron pan, it is so hot, you guys. It is hot enough to sear a steak like you would not believe. So, and then it just, as you guys probably know, it works its way around in a temperature gradation across the top so you can get down to simmering. So there we go, really burning along. Now what I've got for air is I just have been using a little piece of ceramic fiberboard that I sort of wedge shaped to fit in there. You can get sliders, and you know, you could spend some time making something fancy. At this point I've been mostly just experimenting, trying to figure out what the settings are, and really for the most part it's open or closed. There's a little advantage to having this slightly adjustable. You know, I can set this in there like that and adjust it pretty well, but for the most part it's open or closed. As you can see, it's pulling pretty good through there. The fire's going back. When I set this in there, it's going to slow way down. But what we still want to see is the fire way in the back there turning the corner. And we're just, you guys can kind of see that it's kind of turning the corner and lighting off back there. We're not going to be able to see it real well. So that, and this stove's probably a little bit cold for shutting it down. Yeah, I can see it, it's going around the corner, but I'm going to open it back up. But those are my two basic settings. And between those two, you can really have a pretty broad range of temperatures, believe it or not. Like I said, you can open the primary a little bit more, and that'll give you a little bit high, you know, a little bit more control of temps, but you really don't need it. The top is variable, so wide open or all the way closed are pretty much the two settings that I use at any rate. And when it's all the way closed, you can come back, you could load it, shut it down, load a hot stove, shut down the primary, and you can come back about 4 hours later, 5 hours later, and still have a load of coals like I just showed you. They'll get things started again. Now, talking about closing down the secondary air. Now, I have been plugging about a third of the secondary air just with a little scrap of fiberboard there. And what I found is it's the stove runs fairly well like that most of the time. When you plug the primary, sometimes it's important to open that back up again to keep enough speed in the back of the core, the second half of the core, to keep the gases moving. But usually once things are hot, if it's cold enough outside, I'm kind of dealing with some warm temps outside right now as well, so I don't have as much draft as I could. So sometimes you need to keep that secondary air all the way open when you plug the primary to make absolutely sure that you've got enough velocity back there to keep things mixing and combusting. But if you've got good draft and things are going fast, yes, you can slow that secondary air down, plug it a little bit, reduce it a little bit, and you can improve burn times, and you can do that without much harm to efficiency, and in some cases even gain a little bit. But you got to be careful, because if you stall it, you know what happens. So that's most of the air discussion. It's really pretty much that simple. This stove burns amazingly well. Let's turn around and see how we're doing here. So yeah, we're just kind of settling in there to a nice, 300 parts per million CO or so, and our efficiency, even with what I consider a warm stack, when I start this thing in the morning, that stack's like 130, and so the efficiency is actually quite a bit higher for the first few burns. But this is kind of how it'll run all day, is in the low 80% efficiencies. Now again, that's with my testo. You guys, just so you know, you can't compare this with Peter's testo. His seems to run significantly higher in percentage of efficiency due to some European and US calibration differences. So this 83% would be on par with his 90s for whatever reason. So at any rate, here's how we're sitting. Low 80s, cruising along, fairly low carbon monoxide. We're just getting started. That carbon monoxide, in my experience, the first 15 minutes or so of the burn is usually our highest right now, and then it'll settle down after a while. We might not get that far to see it, but I'll try and give you a clip of it later on, and we'll definitely put up a graph of a burn here so you can see what we're talking about over time. All right, so back to the stove. So I wanted to talk about layout options. Now, one of the things that's not very clear or obvious is that the Firebox, the core, the riserless core, within the brick body can be rotated and or flipped if you'd like your configuration to be different. So in other words, you could rotate this 90 degrees and you could have your loading door on a side. You could also flip the box just relative to itself, the two sides of it, and you could have the loading door here if that suited your needs better for whatever reason in the space that you were putting this in. As well, you can spin the top relative to the bottom, so you could have the exit on the other side if that suited your need. You could sort of flip this whole stove over. So those are a few options with Firebox and door. You could also remove this back chimney stack if you needed to make it smaller, wanted to make it smaller. You know, you can see it bumps out there, and there's the chimney. I did that because I wanted more mass, and it gives us a few more options with bypass, but you could certainly delete that, and you could just come right out of the back of the stove through the wall. So that's an option as well. So let's see, benches and bells, of course we know we can add those. We've got plenty of extra power in this stove. My bench is about 6 feet long, I guess, and it's just a hollow bell of brick with flagstone tops. And that gets that stove running, as we can see, typically, you know, around the 80%, low 80% efficiency is as good as, you know, your best wood stoves. So you could, this could be another bell. If you didn't want a bench, it could be Cobb flue run bench, as opposed to, that is a bell bench, by the way, it's just wide open if I didn't mention that, but there's a few ways to do that as well. So we talked about in the intro video, I talked about the possibility of having an oven here in the side chamber as opposed to down low, so there is that option as well. And then we talked about hot water, and what I didn't specify too much is that, you know, this stove, the layout, of course, you got your core, and then the flue gases are coming across and down the body of the stove and underneath the core in that oven there. So what we've got is we've got a large side compartment in here, and that would be an ideal place. It's downdraft. That'd be an ideal place for either a coil type heat exchange or tube type, where you'd build a large tank with tubes penetrating through it. The flue gases would go down through there. They'd be coming right off of the top, which is the hottest point. That'd be a really good place for a fast transfer type heat exchange system. Now, conversely, you could have the heat exchanger in the bottom there. Temperatures are much lower there. I do have a thermometer. It's wired in at about this level, so it's about the level of the door. And as you can see right now, maybe if this will focus, maybe you can't see, it's 304 is what that says. So that's down low. So that'd be a great place for a, come on camera, thank you. That'd be a great place for a tank style heat exchange. Something that was, it's quite large in there. You could probably have a 20-gallon tank in there, and you know, you could have it open to your, well, I won't go into the whole system, but you know what I mean. A slower transfer system down there is a great option. And then you could still have the hot cooking oven on the side. So, here's our fire, here's our firebox. It's ripping, right? We're raging right along there. So, we're doing pretty good on consuming all the CO there. We've got 148 parts per million, 587 adjusted, and this stove does run, like I said, with pretty high excess air, but that still leaves us with pretty darn good efficiency and pretty excellent CO numbers. As I said, we're just going to keep dropping from here. I don't know how long we've been running, 10 minutes or so, but I'll take a few photos and we'll get them in the video. But as we go through the next hour or so of this burn, those numbers will just get flatter and flatter. So, I think that's about it. One thing we didn't talk about was cleaning. We'll do a video on that maybe someday, but it's just, you can get any hardware store should have those little ash cleaning shovels, little ash can as well, little metal ash can, and you can just shovel her out real easy. I do it about every 2 weeks probably. Doesn't generate a whole lot of ash, but there is some, and you want to get it out. And then every year, maybe twice a year, depending on how you're burning, you want to pop the top. And you can get right in through the top real easy. It just takes a few minutes and a few little drips of clay sand to get that top back down once you're done. But you can get in the top, and then you can just inspect the passageways in the rest of the core and make sure that you haven't built up any ash or any crud in there. Sometimes after a lot of burning, depending on what kind of wood you're burning, you can blow a lot of ash in those secondary compartments. Alrighty, that's enough for now. Hey, thanks a lot for watching, you guys. Let me know what questions you have, and we'll come back and maybe go a little deeper into depth with the testo and some of the air settings. For now, this is working pretty darn well just with those simple settings. So hope that helps, and we'll see you guys next time.